Thank you all for making it to the last session of the day, I think. So we are getting in between them and the happy hour.
Exactly. Don't worry, I have some drink tickets in my pocket I'll pass out after, so we'll be good.
All right.
So thank you all for coming. I know it's late in the day, but I appreciate you all here. We have a great conversation today around sovereign AI and world foundation models, and where we see this trend heading later in the year, where I think there'll be a critical point where infrastructure will play a huge role in it. So Shilpa will start off, and then I'll jump in a little bit later. So thank you very much.
All right. So let's get right into it. I'll just set the context around sovereignty and sovereign AI and what that means to physical AI and world models. So if you've noticed, AI has been evolving in stages, in waves, and each one has, in fact, unlocked a new economic value, a tremendous economic value to organizations and to nations. This has been a shift with every generation of AI, all the way from just search and analytics to generative AI to agentic AI and now to physical AI. But what's different this time is the scale and the impact. And it's basically the implication of that is that AI is no longer just a tool, but it has in fact become a national critical infrastructure, critical asset. And for that reason, nations are investing specifically in making AI their own capability and increasing their capability to produce AI. And that's known as sovereign AI, the ability to control and own what matters most, the critical infrastructure, and to collaborate on pieces and leverage what has already been proven. And that's why we are very proud of the partnership that we have with DDN here. And especially as AI moves into the physical world with physical AI and begins to model reality itself, the sovereignty becomes very critical because nations are no longer just managing data. They are actually governing how AI understands, how it reasons, and how it acts in the real world. So there are some challenges, and the key takeaway in this picture is really that sovereign AI at scale is very complicated. It's complex to manage in pieces, which is why you need an AI factory, the concept of AI factory, where as AI adoption grows, the nations are facing complexity around the design of that AI infrastructure in deciding which use cases to prioritize, which architectures to select, and the constraint, the requirements around the deployment and the cost, and picking the right infrastructures and architectures around the security and governance frameworks. Now, another important aspect is how quickly can organizations as well as nations get from just experimentation into production, right? And so as AI workloads are extremely complex and require a very specific optimized infrastructure across compute and networking and storage, that's the reason why NVIDIA has introduced the concept of this AI factory, which is basically a purpose-built infrastructure. It's a full stack infrastructure, which requires more than GPUs. So the key point of this slide is that it's more than GPUs. Every data set, now we love our partnership with DDN because AI comes down to the data and the data set, and every data set is a story that's waiting to be heard. And the way to bring voice to that story is actually through a highly optimized AI architecture, which is the NVIDIA DDN platform in this case for physical AI and for world models. And you need this full stack architecture starting all the way from the foundation, which is, of course, you need the energy and electricity to power it and the data, but also on top of that, the software platform, the training frameworks, the inference, the inference platforms, the orchestration tools, the software application frameworks, right? And the key point is that AI performance depends on the entire system, not just the GPUs. And in fact, one of the most underestimated part of AI infrastructure is storage performance, right? So across the entire AI life cycle, if you look at how it's the data that's moving, large amounts of data that are moving across the GPU into the memory. And so if the data pipeline is not being handled fast enough, then guess what happens? You're not going to get the optimal utilization of the GPU. It's like a very fast race car that's going to be waiting for its fuel, and nobody wants an idle GPU, right? So that's why storage and data movement becomes so important, so critical in these high-performance AI factories, whether it is in the training phase, where very fast access to large data sets is needed, and writing the checkpoints is needed very fast, or whether it's during the fine-tuning, where again you need fast access to curated data sets, and during the inference phase, where systems must retrieve the context and the state of the model, right? So when GPUs sit idle when the data pipeline cannot keep up. And that's why storage, data movement becomes super important. And especially when it comes to physical AI. Early AI worked on text and images. But now, in the physical AI realm, AI is interacting with the physical world with streaming video and with audio. So it's become truly multimodal. And to do that, the systems that we call world models, which Victor will be going more details into, it's the AI that understands and predicts the world. So to dive deeper into what is that architecture that's needed to handle these world models, why don't I pass it over to Victor to take us into what's needed there.
Thank you, Shilpa. So we've been discussing basically everything up to now about world models and how sovereign AI are going to be intersecting together really importantly. So the first question is, what are world foundation models? I'm sure everyone in this room, you've heard of LLMs, you know how they work, the importance of them, probably use chatbots and all the great tools, but they operate in a sequential manner, right? Very predictive of what comes next. So I have a word, what's the next word? What's the next word? Using a mathematical algorithm to figure it out. And it just operates in that linear fashion. But world models are here to sort of replicate what happens in reality, what's happening in our world today. And you all know that nothing happens sequentially in this world. You can have a million things coming at you all at once from different directions. And the whole idea is that you need to be able to handle all that in conjunction and be able to figure out what's coming next. And it all works in a way of cause and effect, that something happens because something else happened previously. So it's going away from just predicting, right? In a way, it is predicting, but what you're really trying to do is plan. You're trying to reason. You're trying to figure out why something will happen and how this event will trigger other events that come around. So what's happening now is this is operating at a national scale. Nations are using this for many different parts of what they're doing. So basically things like defense, power grids, energy factories. It's going to be basically where countries are operating and using AI in many different ways. What's really been helping this is what NVIDIA has built using Cosmos. Basically, I have the numbers listed out, but they built models using 35 million plus hours of video. For most people, that's binge watching, but not really. It's a lot of information, 9,000 trillion input tokens, and over 2,000 hours of training. So a lot of information, pretty much every video feed you can think of, every video you can think of. And the reason why videos are used is that it helps you understand more about the world than you would if you just gave it text. In text, I can give an example saying, somebody cried because they got hit. But watching somebody cry and understanding why it happened might not be a bad event. Maybe they just found out they're having a baby. Maybe they just got proposed to. So there's various events that trigger other events that words can't explain, but visually watching it, you understand what happens. So basically, the world models, in the way that they'll be used, mostly with AI, is being able to plan and not react. So right now you have, say, sensor models that are reading in feeds from maybe an oil rig or from a transformer, and basically it's just watching numbers or something coming through, looking for a pattern. That pattern will trigger an anomaly. The model will say, something's not right here. But what if you can even plan other events? Say we have an oil rig sitting in the middle of the ocean. The sensors are coming back fine. A storm's coming in the horizon. A boat's heading in the same direction. A whole bunch of events are happening where visually, if you're watching it, you can say something's about to happen, where a sensor hasn't picked it up yet. A sensor might pick it up when a pipe starts maybe leaking or something bad is happening, but there are other events that could trigger it way before that happens. And this is what's coming down the line, right? You look at autonomous vehicles. When a car is driving down the road, they're seeing many events all happen at once. And it needs to make a decision based off of the current state and what's going to be happening. So again, robotics, simulation, digital twins, the ability to run real live digital twins or simulations and running them concurrently with other ones, maybe varying different events, being able to make different changes. And you can see where I'm coming here, right? This is a lot of information all coming at once that needs an instantaneous decision to be made. So the whole goal is to be able to reason over time and understand the consequences of the events that lead up to it. And this is where models need to learn and think more like us. So maybe 6-7 months ago, probably longer, Jan LeCun, the former chief AI scientist for Meta, basically said publicly he thinks LLMs will not lead to superintelligence, that they pretty much are at a critical point now that no matter how much more you throw at it, the gain you get from it is minimal. And to really gain superintelligence, you need to understand how the world works and how the world functions. And this is essentially where we're heading today with world models. But there's always a but, right? You think, oh, this is great, everything's amazing. Infrastructure will be critical for this. As you can tell, right, videos, learning state, being able to keep track of where you are at every single microsecond will utilize a lot of memory. The compute demand will be through the roof. Basically, just being able to manage this. You're not looking anymore at tokens or looking at word by word by word or looking at an image and just guessing the next pixel, but you're looking at numerous events all at once, all at the same time. So context is going to be vital, and this is where the state of an event is vital. Typically, LLMs, it doesn't remember what happens anymore. It predicts the next word and forgets about what happened to free up space to continue going on. With world models, though, state is critical. It has to remember where it is, what's happening, and where it's going to go. So basically, there are a lot of things that need to remain in memory that have to maintain that state throughout. So what's really important is that with all this information that you're doing, and especially in sovereign AI, that data has to be local. You can't be moving this data across clouds, between countries, moving it all. Once that latency hits a certain threshold, the entire thing will fall apart. So you need to have everything local, full control, and full management of it. So of course, this is where compute and memory challenges really will come into play. GPUs need to maintain that initial state, but the GPUs will be constantly bombarded with information, video feeds. Imagine having 1 billion robots all operating, and I think Jensen made a statement about 1 billion robots will be here pretty soon. So, I mean, if you just walk outside, I had little robots rolling around bumping into me, and I almost tripped over one. There'll be a day where they'll be pretty much all over. But for them to operate, they have to process data at real-time speed to be able to make real-time decisions, just like we do. So that's going to scale, and the scale will take a lot of context. That context needs to remain. From a single perspective, it doesn't seem like much, but when you start scaling thousands to hundreds of thousands to millions of devices doing it all at once, the GPUs will just become overloaded. Eventually, they'll become a bottleneck. And the reasoning is the GPUs need to compute it. They need to store it in memory. Once that memory fills up, it needs to be offloaded somewhere, and then it has to redo this whole cycle over and over and over. So once the memory pressure rises, it really hits a critical point. Latency will start becoming an issue, and the entire system will collapse. So the important thing when you're thinking about this from like a sovereign AI perspective, right? You need to be able to manage this. You need to be able to control this. You need to be able to have infrastructure that can support all of this. The other thing is, if I'm now using all of my world models for different functions within my nation, I have government, I have defense, I have the energy sector, I have different other ones, finance. I can't just throw all that data in a bucket and then start processing it. I need to isolate it. I need to be able to have each function has its own certain path. So something that has multi-tenancy, the ability to separate that data, isolate that data, protect that data from anyone else from seeing it, and the ability to process that data as quickly as possible. So this is where you need to have predictable performance, predictable outcomes. There is no guesswork in this. You need to be able to calculate this and have this repeatable as everything runs continuously. I don't want, say, if I'm running some manufacturing process using robotics and vision, and today it takes 5 minutes and tomorrow it takes 10 for no reason whatsoever. I need to have this as predictable as possible. So of course, one thing that NVIDIA did to help alleviate this is Vera Rubin. And basically this was designed to help with this giant scale in memory, being able to control the interconnect, the networking, the memory, and the compute. So instead of fragmenting everything and passing it along, causing latency issues, Vera Rubin is capable of managing this and handling this. So when that initial storm of data starts coming through, the GPU can take it, handle it, and manage it through memory and alleviate a lot of those latency issues that you would see with older models. And this will help support the long context that will allow you to have the reasoning without the fragmentation, seamless execution, basically being able to manage things in real time. And again, it just comes down to predictability. If I do something today, I want it to be the same tomorrow, and I want it to be same a year from now. I want to be able to have full control and management of this. The other technology that NVIDIA is developing, of course, is Bluefield and the context memory storage. Jensen mentioned CMX on Monday at his keynote. This is now being able to manage context. This will get rid of that bottleneck that typically will happen with GPUs. Once the GPU is reprocessing the same data over and over and over and over, and that data is not being stored or managed for reuse, it becomes a problem. You want to be able to take the load off the GPU, let it handle more concurrent users, more concurrent processes, and be able to have that data move around, be stored, be reusable, but at a rate where there aren't any throughput issues, without latency, where it can operate in real time. So you want to be able to take the inference and extend away from the GPU and have it in a controlled way. Because right now the way it typically works is the GPU will run it, it'll be stored in the GPU memory, eventually that has to be offloaded to CPU, and then from there it just vanishes, and then the cycle continues again. And the GPU just ends up being completely bogged down. I mean, you want to run your GPUs at 100%. I had a person from NVIDIA come up to me and said, if you're not running your GPUs at 100%, you're not using them right. And that's exactly what we want, but we want them to be optimally run at 100% and not just being bottlenecked at 100% and not reprocessing the same data over and over and over. And this is where we'll get those predictability, and executing it, getting the stateful models, and actually having it being able to store and manage the occurrences of what's happening right now. So what we're doing at DDN, working with NVIDIA in conjunction with this, is being able to have a way to take that data that's been already processed, being able to store it, but be able to access that data in real time. I know some of you are saying, but Victor, if we offload this to storage, it's just going to sit there, it's going to be slow, it's not going to work well. And traditionally, yes, that's the case. But with a high-performance solution where it's able to retrieve that data at real time, and you can remove that latency and that bottleneck, now that GPU doesn't have to reprocess things anymore. The process can actually go find what it's already done, keep that state there, ready to look at, and continuously process new events. And it's not now just getting bogged down with old events. It's able to actually take what it's done, offload it, and reuse it all instantaneously, all in real time. The other important thing is being able to use KV cache. So KV cache will take that information and keep it available. So when the inference process runs, the very first thing it does is it tries to look in cache. It wants to see, did I already process this before? And if it doesn't, it'll go back and do it. If it did, then it saves a lot of time. And just through some tests that we've worked on, about 50 to 60% of GPU uses is just from the initial processing of the information coming in. If you could take that away, now you've freed up about half of the GPU that you can now add more processes to it, more concurrent users to it, and get more benefit out of your GPUs to be able to do that. But again, you need to have a storage solution that doesn't have a bottleneck in bringing that data back. You need that latency to be as quick as possible, that throughput to be as quick as possible, and the ability to retrieve that information back in instantaneous fashion where there aren't any bottlenecks. And imagine now a driverless car trying to make a decision in real time. Every microsecond counts, and this is vital, and this is what we're delivering at DDN. So there's KV cache, which basically is nothing more than just all the tensors, the information that's been stored from being able to process the information and keep it there, with the ability to keep the GPU memory freed up for any new data that's coming through, the ability to keep it offloaded and keep it offloaded as long as possible. So the initial KV cache will be localized RAM on the GPU. And that's going to be fast. It's right there. It's next door to where it's processing. But it's very limited. And these models that are processing massive amounts of video, and again, everything is video technically. A robot looking at you, to it, it's video that it's feeding. It's not like us just, I don't know what you'd say, it's optical, right? But it is video being fed into the robots, being video fed into a car. It's all that needs to be processed in real time. So being able to take all of that, process it, store it, keep the state in mind, and then taking multiple events in concurrence with it and being able to process it all at once, and doing that all in real time is essentially vital. And the goal, again, is just to keep the GPUs processing. The minute a GPU has to stop and wait for memory, or it has to be able to move things between memory, then that latency becomes an issue. So a few things we've done with CMX, and we've been working with NVIDIA on this with our Infinia platform, is the ability to offload a lot of the data to KV cache, but in this case, KV cache and storage, not in memory. And at a certain point, time to first token, as you scale up users, will stay pretty equal. Once that memory fills up and it needs to be offloaded, and if it's lost and you have to reprocess it, then you'll start seeing, as you can see without KV cache in the red line, that time to first token starts to get slower and slower, because now the GPU is starting to get filled up, it's starting to reprocess, it's getting pretty much bogged down. By offloading that and freeing up the GPU from recomputing each time in the blue line, you can see that time to first token stays relatively flat and you get a great benefit from it. So from an end user perspective, I'm not seeing any latency issues. I wouldn't notice it. In any sort of automated process that's running it, there wouldn't be much of a latency issue. That it's able to get back the response almost immediately, and you're able to store that now in data storage, not in memory, but having it act just as fast as memory would. Here's a demo that we have at our booth that we worked with NVIDIA on. It's a tax assistant that can run through all of your information. If you come by, we could run you through it. But it's running with RTX Pro 6000s, using Spectrum-X Ethernet, and using NVIDIA BlueField 4. And through this demo, what we were able to show, if we weren't using CMX, you can see the red line basically how much longer it took for time to first token. By implementing CMX, we were able to speed it up by 5x. And these are just initial tests that we've done. As we scale this up, these numbers will start to even grow a lot further. That gap will widen where we're able to keep time to first token relatively low. And as you scale, you'll see time to first token take a lot longer. So CMX is playing a vital role right now. And using Infinia from DDN, it's basically helping alleviate any of these latency issues, and it's able to actually speed it up. So I'm going to pass it back to Shilpa. She'll talk a little bit more about sovereign AI.
Yeah, so as Victor explained, world models, like the trend of long context reasoning, physical AI, and world models all coming together requires the stateful AI architecture, and how the shift has happened from stateless to stateful AI architectures. And so the key takeaway here is how the NVIDIA and DDN platform together are providing that scalable infrastructure with the inference memory that's needed to process these humongous amounts of data. The predictable performance that's very essential to give that low latency response, and along with a very strong data governance, right? As I said, physical AI is, world models are predicting how models are going to actually reason and act in a real world. So that's where you need a very strong data governance, tenant isolation, security. And hence, this dramatically increases the amount of inference memory needed. And at the same time, the architecture has to guarantee that deterministic, predictable inference latency, data residency. So together, we are delivering a memory-native AI platform that enables all these capabilities. And really, to make this more concrete, here's just a couple of examples, but we have many more across different industries, such as manufacturing and healthcare, which you can see at the DDN booth. But these ones are about deploying large GPU, nation-scale GPU clusters. Actually, I shouldn't say GPU clusters, but the AI factories, including an intelligent data platform with DDN and NVIDIA, which is enabling the AI workloads at nation scale without relying on external infrastructure. And it's enabling, in this case, Thailand has a national AI cloud enabled by cloud provider Siam that is able to build AI applications enable different types of use cases. And another example is Alaria in UAE, which is focusing on building digital twins with that infrastructure. Now, the unique thing about the Alaria platform is that it's actually operating AI factories with extremely high GPU utilization, which is what we want. We don't want idle GPUs. And so that's able to provide a very high GPU utilization while maintaining a very strong security and tenant isolation, right? So this enables governments in a very sovereign fashion, governments as well as industry, to build AI that power applications, whether it's digital twins for smart cities, actual industrial factories, simulating the environments and providing those advanced decision systems. So with that.
Yeah, so you can just see now like where the trend is heading, right? that the world needs to start using AI in what we call real AI, the importance of being able to work as reality, the way we see the world, not as language sees the world. So being able to predict events, plan events, simulate events, and being able to do this all with instantaneous speed, the right compute, the right data, the right memory, being able to have everything that works in conjunction with full infrastructure. So exactly what NVIDIA is doing for compute, DDN is doing for storage, and working together, we're able to have infrastructure that can fully support this, literally at a national scale. So it's very interesting. I mean, if you haven't worked with world models or heard about them, definitely research them, see what's going into it. On NVIDIA's website, you can actually go and look at Cosmos and actually work with world models. You can load videos, you can test them, you can see the predictability of them. So there's a lot of interactive features with it. Definitely come by our booth. We're just, as soon as you come out, you turn right, you'll see this big DDN booth. And we have a lot of interactive demos. And in GTC Park, we have a big bus. We're inside as well, 6-foot screens. You can try different things. You can see how this works. Video semantic searches, video processing, everything around that as well. So with that, we have a few minutes left. If you have questions, we'd love to hear them. We'll try to answer them if they're not too hard. If not, we can just wrap up. So thank you all for your time.
Thank you.
Questions, anybody? No? All right.
But only easy questions.
Yeah. We got one over here.
Thank you. Yeah, I'm curious when you mentioned a lot of times you put the word nation. So from NVIDIA strategy, I wonder if governments are also part of this strategy, and what role do they play?
Mm-hmm, yeah. So AI nations is really that effort where countries are trying to capture the opportunity that AI presents and use AI for the nation-scale transformation. And nations, about 80 nations in the world out of the 190 have already devised a pretty strong AI strategy with the important pillars that they want to focus on. So definitely compute infrastructure is one of them, but there's also a lot around the data and the governance and the talent frameworks and the ecosystem. So in that way, yes, nations are forming, governments are forming public-private partnerships to accelerate the adoption of AI for their own transformation.
Yeah, because essentially you're trying to take what your nation does today and simulate that in the digital world, right? So the data that's being involved in that is very highly sensitive. This is how your nation runs, from energy, from defense, from finance. That has to be critically controlled. You can't just start copying that across the network to different clouds and trying to run. It needs to run in-house, needs to be fully governed. Everything needs to be fully secured, encrypted in rest, encrypted in flight. Because this is how you're operating as a nation, and you don't want anyone else outside of that to see that. So this is becoming highly critical now to have the right infrastructure to support it, to be able to manage it, and be able to have everything run in real time, just like the world operates today. So, yeah.
Got one more here on the right.
Thank you for that talk. Excellent. Thank you very much. Shilpa and Victor, if you had to give your top 3 recommendations, what are the top 3 priorities nations should focus on for implementing sovereign AI? What would they be? Just a few bullets.
Okay. You know, it's something. So I just met Shilpa in person for the first time today. And when we were going over the presentation, she said something to me that sang in my head, because I've been saying this for years, is your data has to tell a story. Right? If your data does not tell a story, then how do you expect it to operate in a model? How do you expect it to do something that you could predict off of? And the important thing is having the right data, having the right data sets. With that, you now have the fuel, right? You need an engine to operate, so now you need the compute to do that. You need to then be able to marry the two. have that data feed into that engine as fast as possible. If just interestingly, years ago, before I started really learning a lot about how GPUs worked, I start training models, I throw all the data at it, and I'm looking at it, and it's not going past 30% utilization, and I couldn't figure out why. And I tried everything. I started running other ones and other ones. The problem was the GPU was just keeping up as fast as I can feed it, but I wasn't feeding it fast enough. So we were wasting literally 70% of what was capable. What would end up happening is one of our data scientists would start training a model, and everyone else would have to wait in the queue for 2-3 days until they were finished so they can start. Because we didn't learn that you have to feed that. If I was able to speed that process up and finish it in less than a day instead of running 3 to 5 days. And these are little critical things that it's easy to forget, it's easy to overlook, right? It's kind of like this holy trinity of compute, networking, and storage. And once you've nailed that down, and once you can do that, then you have predictable outcomes, especially now with world models. It's not applications anymore. It's literally critical infrastructure for your nation. These are things that you're now depending on. This is business critical systems. So you have to be able to predict it. You have to be able to see where it's growing. You have to be able to manage it. If it goes down, things stop. It's not like before where I could run an ad hoc test, build a model to make a prediction, make a finance prediction. And if it didn't work well, that's okay, I could rerun it. Today, AI is basically business critical systems, and they have to run just like any other system that you're running your businesses on. So yeah, so the key is to have control of it, have everything necessary, be able to predict the outcomes, and be able to manage it fully. And sorry, do you have anything else you want to add?
That's a very important element of that, is to have that highly efficient AI factory with all of the considerations around the data intelligence pipeline. And also, eventually, it's about the sovereign aspect, which enables organizations and nations to retain the value that AI is generating within the nation. So it's about economic growth and value, and being able to capture that value and retain it within the nation. So that's all about sovereignty and the ability to produce AI and not just be an AI taker, but an AI maker.
Thank you for that. Just in that same line of thinking, what do you feel is NVIDIA's mission in guiding nations? Is there a specific mission that we can learn from?
Well, NVIDIA is taking, from the architecture perspective, a full stack approach with partners and ecosystem, but also at the highest levels, we are trying to align with the national AI strategies, which include aligning with the startup ecosystem and the ecosystem of researchers and innovators and academia and the industry to propel the overall national AI forward. This is about democratization of AI, because the full potential of AI cannot be realized unless everybody knows how to use AI.
Okay. Thank you guys very much. One more round of applause for Shilpa and Victor.
Thank you.